A feather is dropped on the moon from a height of 1.40 meters. The acceleration of gravity on the moon is 1.67 meters per second squared. Determine the time for the feather to fall to the surface of the moon. So if we have a feather here, and it falls down, because it's down, we know that this is negative 1.40 meters. The acceleration due to gravity on the moon equals negative 1.67 meters per second squared. And we know in the beginning velocity initial equals 0 meters per second. Given these things, we can go distance in the y is negative 1.40 meters. And that negative is going to become important when we do the math. Acceleration in the y is negative 1.67 meters per second squared. And our velocity initial is 0 meters per second. The thing that we're trying to find is the time, and that's going to be in seconds. The equation that we're going to use is displacement equals velocity initial times time plus 0.5 times acceleration times time squared. So in this case, we know that displacement is negative 1.40, and that equals 0 times time plus 0.5 times the acceleration due to gravity on the moon, negative 1.67 times t squared. Now any number multiplied by 0 is 0, so this blows up, and we're left with negative 1.40 equals 0.5 times negative 1.67 times t squared. Now I can simplify this a little bit right here. I'm just going to write the left-hand side again. And when I do the math, I get negative 0.835 t squared. In order to get this number away from t squared, I'm going to divide by negative 0.835. And the reason I do that is so that this cancels. But whatever I do the right, I got to do the left as well. Divided by negative 0.835. When I do this, I get t squared equals 1.67666467. And in order to get rid of the square, I do the opposite. I take the square root of both sides. This means that time equals 1.2946 seconds. Okay, now it's time to apply significant figures. This has 3 sig figs. This has 3 sig figs. And this number doesn't apply. So my answer is going to have 3 sig figs. And so I get the number 1.29